Previously, we had discussed position functions and what they tell us in terms of particle motion and simply straight line motion. And now we're going to discuss the relationship between velocity and position. We know that velocity is the change in position over time. We also know that the change in position over time is a derivative. And so the relationship between velocity, which we'll denote as v of t, and our position function s of t, is that velocity is the derivative of a position function. So again, velocity is the derivative of a position function. So that's a relationship. Now, a couple things that are important about velocity. Right? Velocity is called vector motion, which means at this point, what's important about that is that you understand that that means it has magnitude. How fast are you going when you're talking about velocity? And velocity has a direction. Am I going to the left or to the right horizontally? Am I going up or am I going down vertically? If a velocity is greater than 0, and we're talking about being on a horizontal line, then that means that the object is moving to the right when velocity is greater than 0 or positive. If we're talking about a vertical line, then that means that our object is moving up. Now, when velocity is less than 0 or negative, then on a horizontal line, this means that our object is moving to the left. And on a vertical number line, this means that our object is moving down. And when our velocity is equal to 0, then in both cases this means that the object has stopped. It's neither going left or right, it's neither going up or down, it's simply not moving at all at the instant the velocity is 0. Now let's contrast this with speed. Speed is not a vector component. Speed is not concerned with direction of travel. And so speed is related to velocity in that the speed of something is the absolute value of its velocity. The speed of an object is positive or it is 0. Right? Something has no speed or it is moving. Something can have a negative velocity because that just would denote direction of travel. Now, acceleration is the change of velocity over time. And so then when we're talking about acceleration, we're talking about the rate at which the velocity is changing. And since that's the rate of change of velocity, then a of t, which is what we use to denote acceleration, is the derivative of v of t. So if you have a position function and take the derivative, you now have a velocity function. And if you take the derivative again, you now have an acceleration function. Acceleration has some properties similar to velocity in terms of horizontal and vertical lines. If we're on a horizontal line and the acceleration is greater than 0 or positive, and this means that the object is accelerating right, which is different than, so it's telling us the rate at which it's the direction that it's speeding up. And for a vertical motion, when acceleration is positive, that means it's accelerating up. And this is kind of a weird idea to think about, but this is the direction of the acceleration. right? The word decelerate doesn't actually make sense mathematically. We're just talking, we only accelerate. We can accelerate in multiple directions. When acceleration is less than 0 or negative, then the direction of our acceleration will be left horizontally, or it would be down vertically. And when the acceleration equals 0, this means the velocity is not changing. Right? The velocity is staying the same. It doesn't mean the object hasn't stopped. It just means the velocity is the same. So it's like if you're driving and you've got the cruise control on, and that means that your velocity is staying constant at 65 or 75 or 85, depending on what you're driving. Right? So the acceleration would be 0 at that point. Now, just because you have a positive acceleration doesn't mean you're moving to the right. Right? Let's say that we have an object that started here, for example, and is moving in this direction. Well, that means its velocity is moving in this direction. That means it's traveling in that direction. But the object could have acceleration in the opposite direction. Right? And in this scenario, when your velocity is in one direction and your acceleration is in the opposite direction, this is a scenario where you are slowing down, because the acceleration is working against the velocity. So let's say this velocity was, if we want to give it a number value, negative 50. But the acceleration is in the opposite direction. Then that means that the velocity would be going from negative 50 to negative 49 to negative 48. It's going to be slowing down. And it's when the velocity and acceleration are in the same direction that you're actually speeding up. So we'll be looking at more of this in the next example. This gets us at some notation and some factors relating velocity and acceleration to position.